Hello. Today we will look into IEC 61499 standard. So this is a component-based open reference architecture for distributed industrial process measurement and control systems that was proposed and developed by International Electrotechnical Commission, IEC. That is one of major standardization bodies in the world. And this standard was published in the first edition in 2005, and the second edition appeared in 2011. While the whole project on the standard development started already in 1992. The standard aims at addressing current and future requirements for intelligent automation. And although it has been developed quite a long time ago, it is still a very modern technology that yet to be adopted by industrial automation world. The main artifact of the architecture proposed in the standard is a function block. And by that, it bases on two previous developments, one of which is PLC function blocks language that is known from IEC 61131-3 standard, and another is a concept of function block that was developed for distributed control systems in the proposal of IEC 61804 standard that hasn't become standard but was published as an open specification. So what does IEC 61499 contain? What are its main components? It's well known for being a language for distributed systems programming. It's a visual language, and here on the left hand side of the screen you see an example. You see an example of automation program in IEC 61499. That is a network of function blocks connected with data and event links. But in addition to this visual language for describing entire distributed system, it has several important elements. And these elements are provisions for intelligent automation, which include portability provision, configurability provision, and interoperability provision. What are these? So portability. What we want is to be able to program our automation devices such as PLCs and motion control devices and all other kinds of robot control devices and so on and so forth, program them from tools of different vendors. So the standard addresses this need by allowing to exchange programs using portable XML format. So the XML representation of programs is standardized already in the standard. It was not the case for example, IEC 61131. In addition to portability of programs, we also want configurability, meaning that PLCs of any vendor to be configurable by tools of any other vendor. And the provisions of that is a standard management protocol that is also defined in 61499. It also uses XML as a basic representation, which is a self-explanatory representation, and this protocol is a part of the standard. And one more element one more requirement of future automation systems is interoperability. Interoperability means that controllers of different vendors should be able to talk to each other and exchange data between each other, not with a proprietary protocol, but in some standardized way. And again, IEC 61499 relies on data representation, data transfer protocol IASN1 that helps in representing data in an interoperable way, and by that tools or automation devices can exchange data between each other. Okay, and what is interesting to know is that IEC 61499 was developed by very same working group of IEC that represents experts from major automation companies, very same group of people who developed previously IEC 61131 standard. And after the work on IEC 61131 was completed, the next goal was to address requirements of future intelligent and flexible systems. And that was already clear by then that future automation systems will be distributed, meaning that they will include many PLCs communicating with each other. And that development of that was done in the IEC working group by experts from Siemens, Rockwell, ABB, Schneider Electric, and so on and so forth, companies from all around the world, the best experts in automation. That development was going in parallel with Hellenic Manufacturing Systems project. That was an international project running under a parent organization called Intelligent Manufacturing Systems. Intelligent Manufacturing Systems was a huge international project started in 1990s to develop automation systems and manufacturing systems that will be flexible, reconfigurable, and intelligent. And that development was a major prerequisite for Industry 4.0 that appeared much later. So main research work was done already in that IMS project. And inside IMS project there was a Hellenic Manufacturing Systems Consortium project whose goal was develop intelligent manufacturing through Hellenic modules. Hellenic meaning autonomous and cooperative modules. So the feasibility study in that project started in '93, as you can see on the slide, and active development of the standard started in '92. And what was happening is that Hellenic Manufacturing Systems project was providing requirements to the working group of IEC 61499. And the working group has implemented these requirements in the 61499 controls architecture. By that, providing provisions for intelligent automation architecture. So the development of IEC 61499 is very much grounded in the needs of future manufacturing systems and is done by the best available experts in the automation world. Early evidences of this work, which is quite interesting to note, is this paper written in '95 by Ronald Shoup and Alan Streltsov from Schneider Electric. And this paper presents first drafts of first sketches of the future IEC 61499 standard. As you see, the concept of new function block that combines not only data but also event flow, and the distribution model, as you can see here in the lower side of the slide, that implies that the entire distributed system can be represented as one project in IEC 61499. So, what does the standard consist of? There are four parts was developed. Part 1, which was released in 2012, and it was standardized as an architecture. Part 2 represents software tool requirements. It also was standardized in 2012. Part 3 was withdrawn, and that included some tutorial information. And this part is still available as an open document, and it's still very useful for those who are interested in IEC 61499. And part 4, that is rules for compliance profiles. So in the future sections of our course, we will cover mainly part 1, the most interesting part, that covers the architecture proposed by IEC 61499.